Hello everyone, and hope you're doing well and staying safe. Thank you for joining me for another session on Entity Framework Part 2. Quick recap: in Part 1, we set up our file-based SQL database, having a very simple table to pull data using Entity Framework. We also went over the basic introduction of LINQ and Lambda expressions. In this session, we're going to look at complex tables, like how to join data and get that and retrieve that data. We'll use the Microsoft sample database, Northwind, to retrieve that data. We'll do a quick review of what Northwind is and its structure, so we can use Entity Framework. I will put a link in the description so you can follow along. That's it. Let's begin. Here we have our Visual Studio project we created in Part 1 and our file-based SQL database, and we're connected using Server Explorer. We also have our Docker container where we have a SQL server running, and using the Management Studio we're connected to our Docker SQL service. And if we go to our browser, we are at the Microsoft GitHub repo where we can get the Northwind database. Once we have the Northwind SQL file selected, view raw to see the raw SQL file. Next, we're going to select everything and copy it. Then we go to our Management Studio where we are connected to our Docker SQL server and create a new query window and paste our SQL content we copied before. Now we have to do a quick parse of the file, and we can see that the Northwind database is not created. It's not an error message, we know that. And by running the query, it will do that for us. So let's just do that now, and after a short while, the database is created. And if we refresh our Management Studio, we can see our new database. Back to our Visual Studio Server Explorer, where we attach to our file database. We also create a new query window and paste our SQL code. Since we already have a database, we should not create the database file. So let's go ahead and delete the SQL that does that. Next, let's delete the existing table we used in Part 1, so we have a clean database. Now let's go ahead and run our script. Now that process is complete, let's take a look at the tables and other objects created. So here we showed you both ways of doing this, and you can decide which route you want to take. In this session, we will continue to use our file-based database. Now let's do a quick review of the Northwind database before we actually start using the Entity Framework so we know how the database is structured. Here we have connected to our SQL Server Management Studio because we can use the database diagram to visually see how our tables are related to each other. To quickly show you how we did this, it was to create a new database diagram, then add all the tables from the database. If the tables have relationships, then they will show up and link the tables for you, as you see here. The Northwind database example already has a relationship, and you can see it, of course, in the diagram as mentioned before. The Northwind database is comprised of tables that hold data for a fictitious company called Northwind, and views that abstract a structure on top of one or more tables to look at its data. Then we have stored procedures that can extract data in a more controlled manner, for example, generating a report on which employee has made the most sales, and there are a bunch of other examples here that we could use. Looking at the tables, we start with employees. This table holds Northwind database employees, and looking at the table, we can see that we have a self-referencing relationship. Using this, we can extract a reporting structure as far as which employee reports to who. If we examine the properties of the relationship, we can see that in General section under Tables and Column Spec, we find how this relationship is set up. The employee ID is the primary key that maps to a column reports to, which is a foreign key. And this is generally how relationships are set up in SQL Server. If you're new to databases, this won't make much sense to you, so let's take a look at it visually. Again, this is a very quick introduction, and we won't go too deep into database design or normalization of a database. At some point, we may have a tutorial for that. That said, let's get all the data from the table. So how do we extract the company's employees structure? All we have to do is get the top level of employee. That would be an employee that does not report to anyone else. So in the reports to column, it should either report to itself or it should be a null or blank column. Once you find an employee, you can easily check if the employee ID is in the reports to column, and you can find who reports to that employee. If you select an employee ID and no records are returned for reports to, then the employee doesn't have any reporting to them. So we're taking a top-down approach, but you can also do this from bottom up as well. That was a self join where a table will relate to itself. Let's see a relationship with other tables. So what we want to know is the employees and the orders placed by them. So what we would do is go ahead and do select star from employees, and we'll alias this as an E. And then we're going to use inner join. Inner join as equality on, let's say, orders. And we'll alias this as order O. So then we're going to say this join is on E employee ID, where equals to order employee ID. Now we're going to fix this up to where we want very specific values. So we want E employee ID, and let's pick the employee's first name. And for the order, let's pick up the order ID. So let's go ahead and run this. So now we can see all the orders being placed by each employee. Now there's other ways of doing this inner join, and we'll see that in one of the stored procedures coming up, where you won't use the inner join, you'll just do it in a where clause, but the where clause would be very similar to what we have back here. We just need to have the keys, the foreign key and the primary key mapping. So next, let's take a look at the views. So when we go in here, these are the views. The views are very similar to tables when you're extracting information. So you can just say select star from, let's say, alphabetical product list. Let's just run this. And as you can see, it comes back as a normal data in a tabular format like you would have as a selecting of the table. So if you were to open this up, you can see the same columns as you would as another normal table. But if we go to the design of the view, as you can see, this is actually joining two tables. And we're basically taking categories and products and joining that together. And if you were to look at the select statement, that is picking up the categories and are joining it to products on the category ID to category ID. So this basically is getting all the products and it's getting the category name. So here we have the categories, and these are all the products that are available. So you can actually have other tables in here as well if you want it, but for this view, looks like they're just using two tables. So now let's go ahead and take a look at the store procedures. So if we go to programmability, and then let's take a look at this store procedure, the customer history, and basically it has a parameter of a customer ID. It expects customer ID, So how you would execute a store procedure is a little bit different. So you would just use the execute command and then the custom order history. And then as you notice, you need a customer ID in here. So to get a customer, let's actually do a quick select of all customers. So we can get a customer ID, and let's just choose the very first one. So we'll use that. As you can see, it's an nchar5. So we'll go ahead and execute this. So when you execute the store procedure, it's returning two columns of the product name and the totals. So now actually let's go take a look at see how this is done. You could use the modify, or you can script it into a create statement to see actually how the store procedure is created. So we have the create procedure, the name of the store procedure, and then notice that it's expecting a variable of a customer ID. Then we just have a normal select statement with a where clause, and then we group it. So the customer ID is being used where we're saying that the customer ID must equal to the customer variable that we're passing it. We're also doing a product name, but we're also doing a sum. And then here we're doing a group by. The group by basically takes these two columns and groups it together. And that's how you're able to see the, let's close this. That's how you're able to see the totals and the product name, and there's no duplication. That's because it's grouping everything and then totaling it. So now back to the store procedure, and notice that if you look at the from, you just have the product table, order detail, orders, and customers, but notice they are all separated by comma. And then in the where clause where we have the variable, then we have a end condition, and in the condition we have the basically that join that was going to happen between them. So instead of using inner join and then on these columns, they place this in the where clause, which is pretty much the same thing. And basically we're saying that where the customer ID from the customers table and the customer ID from orders table matches, and the order ID from order table to order detail to order ID, and then order detail to the product, and that's how the joins are happening. So this should give us a basic understanding of the Northwind database structure. Let's see how we can use these objects through Entity Framework. So in part one of our Entity Framework, we got data from one table. Now let's get data between two related tables. And we're going to choose the categories, and we're going to choose products. So if we go to our SQL, notice that we have our categories and products, and the way the relationship works is that a category has many products and a product has one category associated with it, using the category ID, a foreign key in the products, and a category ID as a primary in the categories. So we cleaned up the database context so that it would just have the connection string and using SQL Server. Now this was done on configuring. The next thing we need to do is actually now create the classes for category and products. So let's go ahead and do that really quickly. We're just going to do very few properties for these. We don't want to create everything just to show the relationship working. And then we're going to have one more in this property. This is actually going to be a list of products. So I'm just going to use the I collection. And we're going to specify that this is going to be a product. Now we don't have a product object created or class in this case, so we'll just stub it out. And now we can go ahead and create the product class. Let's take a look at the columns it has. So we'll just use very few. And then we're going to have another property which is going to have our category, and this is going to be our category object. So now that we have our object created, what we need to do is tell it that this object and this object is related. And we do that by overriding another method in here. So it will be protected override. And this is going to be on model creating, and this is going to be a model builder. And in here then we will use the model builder to set the relationship. We're gonna just say model builder, and then we're gonna say entity. Which entity do you want to relate? We're gonna choose product, and then we're gonna tell it that it has one category. So it's going to be category, and it's now the category has with many products. And now we need to tell it the relationship. So we can actually use the has foreign key. There's other ways to do this, but in this example we'll use this. So it's going to be our category. So we forgot because we're not returning anything, we forgot to put the void in there. That's why I was getting the error. So now let's take a look at how this relationship actually works. So we're saying that the product object has only one category, which is done through this category ID. And then this object will actually fill in the category object for us. So this category ID is related to this category ID. So here we're saying we have a category with a relationship of products, and the join is based on the category ID. So now that we have this, we can go to our program and set up code to be able to get this data for us. So we're just going to do var db context, and it's going to be our db context. And then let's just do var categories. It's going to be our db context dot. So the reason this is not working is because I forgot to set the db sets, right? So we need to have two properties here, and this is going to be our db set of category, and this is going to be categories, and this is going to be our product. There we go. Now that we have that, we should be able to now say we should be accessing database 1 context, not the DB context. So now that we have the categories, we can just do toList to get all of the categories. Next, what we need to do is do a for each loop, and we can say category and the collection of categories, and then do the console not write line, and then category name. Next, what we need to do is get all of the products, and then do another console.write line, product name. What we're gonna do is we're gonna tab this one. Okay. Now, when we run this, we're actually gonna get an error, and that's gonna be because the products will be all empty. So go ahead and put a breakpoint here. Let's go ahead and run this. So we'll get the first category name written out, but when we go to get his products, there won't be anything there. So here we have beverages for the first category, But if we look at the category and its products, it's actually a null object, so it's going to throw an exception. Now, why didn't we get all the categories products? We didn't because we haven't told it to go fill in all of the products for this. So to fix this, it's pretty easy. We'll just do two categories, and then we're going to say include. And what we're going to include is going to be products. So now if we run this, it should go and get the categories and all of its products. So here we have our beverages, and if you look at the products, we have 12 of them. So let's go ahead and run this. And here you can see that we have all the categories, and we have all the products associated to those categories. So there's a couple of ways to do the relationship here. And if you go to the documentation on the Microsoft website on loading related data, there's actually three ways of doing this. There's the eager loading, explicit loading, and lazy loading. So each one has an example of how to do this. We did the eager loading using the include, and you have the explicit where you explicitly tell it how to load the data. And then you have a lazy loading. It will only load the data when you're accessing the data. Otherwise, it will not. So there's three different ways of doing this. So this was a very quick example of how to do relationships. Now, this was a lot of work because you have to manually go do things. Because we already have our tables and our views here as well, because you can use views as well, similar to tables, and getting data from that. So how would you go do this without having to write all this code? Now to do that, we would have to go and load a NuGet package. So let's go to our NuGet packager manager, and we'll go to browse. And in here, we're going to use the Microsoft Entity Framework Core tools. And click install. Click OK. Okay, now that's been installed, we can actually go and so now we can go to the package manager console and be able to scaffold everything that we have to get this going. Now the command for this is going to be scaffold db context. And then we're going to pass it the connection string. So we can get our connection string from our class, db context. And then we're going to tell it that it's going to be for Microsoft.Entity Framework Core.SQL Server. So now if we typed everything correctly and there's no spelling errors, this should actually go and generate our objects from our database. Now it's going to look a little funky because we're only giving it two options here. We're passing the connection string and we're telling it that this is for SQL Server. So now if we execute this, okay, so I must have had a spelling error in here. So let's take a look and see if I have this correctly. Microsoft dot, I have two T's in here. So it should be entity. Let's try it again. Okay, so now it went and generated everything for us. As you can see, we have a bunch of new objects in here, and we have this DB context that was created for us. And also you'll notice that you have this sensitive information that's part of the connection string that we are using. So if you do have a connection string where it has, let's say, the username and password, you would want to follow this link to be able to get the connection string to be secure so that it's not visible as clear text. Now let's review the generated tables and views and see how the auto-generated code and what it did for us. So the first thing is that you'll take a look and the name is very long. And the reason for this is because we didn't specify what the class name should be when we ran the command. So it basically took the path and removed the spaces and the colon backslashes. So it really was C colon backslash temp backslash EF bench, and then there was the actual path to the database MDF1. We can go ahead and change this without having any issues, and then of course any references are made to it. We'll have to be modified as well. But since this is auto-generated, the only change that would have to be done would be in here. So we'll keep this, even though it's very long and a little confusing, we'll keep it there for now, and later on we can change it. Then it created a to constructor for us, and then with this one it has the DB options, and we're making a call to the base class that we're inheriting. Next we have our DB sets, and there's a lot of them. And if you take a look at these DB sets, there's way too many versus the tables that we have in here. And that's because the auto-generated code went to the views as well and generated those DB sets as well. So if we take a look at this alphabetical list of products, as you can see, that's this view over here. And the name basically removed all of the spaces and fixed the capitalization for the name, so that it would be similar to the standards that we use in C#. Next, as you can see, the categories is a table that's also in here. Now let's take a look at see how the other methods and options are set up. You'll also notice that we have some red lines over here, which means that we have some errors. And these errors are due to the category and products information that we have already created in here. And they're clashing, and the reason for that is because the namespace that we are using, it's exactly the same, and these classes are named the same, and so they're having some issues because there's ambiguity between the naming. And we'll come back and fix those as well by, actually let's fix that right now by commenting this information out. And let's go ahead and comment this in here as well. And let's go ahead and save that. So now all of those errors will go away. So if we come down to see the on configuring, you'll notice that this is exactly the same. Where we had before, we're telling it to use SQL Server, and then we're giving it a path to the file of the database. We also have this warning in here, and this is about the sensitive information in the connection string that you had. So we'll go ahead and delete this. And then when we go to on model creating, where we do the options and to set up and configure the objects that are created based on the tables, you'll notice that we have some additional information here that we haven't seen before. And so now let's take a look at what all of this means. Now we're not going to go over every single one of these, but you should be able to have some idea based on the few that we will go over. The first one is we are taking this view over here, and we are making a object out of it, and then telling it how that object is set up in the entity framework, or how to use it. And you notice the first thing is it has no key. The has no key, as you can see here, there's no primary key in here. If you were to look at a table, you'll notice that it has this little key icon here that signifies that this is a primary key. And a primary key basically is an identifier to uniquely identify a row in a table. So if I was to take this, and let's open up this definition, you'll notice we still have that little key identifier for the category ID. And now if we go to the category ID, it's a identity, and it's not null. But then if we look at the constraint, you'll notice that it is the constraint is a primary key and a clustered index, and that is set on the category ID column that is over here. So this primary key basically identifies this column as unique. So if we go in here and we say show table data, we have all our columns. Now, what would happen if we had multiple category names that are the same? Perhaps maybe another beverages, and in this one it would be, for example, 9, and it would be beverages, and this would be, for example, alcoholic beverages rather than soft drinks. So that's how you can identify that category ID of 1, beverages, is soft drinks, and category ID of 9, beverages, is alcoholic drinks. So that's how you identify the primary key. Well, the view does not have a primary key, and the reason for that is because this view is an abstraction over one or more table. So if we look at this definition, we'll notice that this is joining categories onto products. So we have some columns from products and a column from the categories. So the next thing is that we need to bind this to the view. So we are telling it this is the view's name, and that's how it is bound. And then here's all the columns that are we are extracting from this view into this class that we have over here. So if we go to this definition, here's all of these values, and that's how all the properties are mapped. So now let's take a look at the category, which is a table, and it is not a view, and it has an index of category name. It has a property, which is category ID, and then it has some other properties associated here. If we go to the definition, well, that's rendering. Notice that this one says has index on category name. The reason it has an index is because we have a non-clustered index on the category name. So therefore, it's identifying that the category name column has an index. And if we continue going down, so now let's take a look at a little bit more complex type. We'll choose customer in here. And if we go down here on the where the relationship is happening, we have customer types to customers, and then we have a dictionary object to the demographic and customers, and how this is actually joined. So let's go to our SQL, where we can see in the diagram a clear picture of how this is. As you can see, now we have a customer table, have a one-to-many relationship to the customer demo, and then we have another relationship, many-to-one customer demographics. And basically what these three tables are showing us here is that we have a many-to-many relationship, meaning that we have one customer that could associate to many demographics, and many demographics can associate to customers. So if we take a look at how the relationship is set up in here to represent the many-to-many that we saw here, how the customer is related to the customer demo to customer demographics. So if we take a look at this relationship, it has many relationships to customer types and customers, and that is defined here. So here we're saying that the customer demo has one relationship to customer demographics with many relationship to customer type ID, which is the column. But then you also have this other method that says onDelete, which describes a behavior. And that basically means that if you were to delete a record in one of these tables, it should go and delete the references in other tables as well. So this is the way the auto-generated decided to create this relationship for us. So you can go ahead and study this and to figure out how the rest of this works. But for the most part, you wouldn't, once you run the auto-generated, you wouldn't have to come in here and modify this. Unless you were going to go manually create this, you can go ahead and study this or read the documentation online and how to do many-to-many relationship or some other complex information that is associated to the entity. So now let's go back to our program and see how we can actually use the same code that we had here with the DB context, except that we're not going to use the DB context. We're going to use our new DB context, and that's going to be our C temp database context. And as you can see, because the categories and products and such were all named properly, we should be able to retrieve the same information. So let's go ahead and execute this. And as you can see, we have our list of categories and all products, same as before, retrieved for us through the auto-generated code. So this was how you retrieve information from tables and views through the auto-generated code. Now let's figure out how to actually associate and retrieve data through using store procedures. How would you actually bind this to entities? We'll do that next. So before we execute a store procedure, let's take a look at something. When we were able to get the DB context, we could actually call the databases, right? So if we get the, let's say, customers, and now we can pretty much do anything, do to list or anything like that. We can also do something else where we can actually execute SQL queries raw, but on this one, you're bound to the context of this customer, meaning that this is a DB set that is mapped to, so if we go back here, so it's a DB set of, let's say, customers. If we go down here, there we go. So it's mapped to this class customers. So it has to map whatever the query you're executing, it has to map to customers. So we can then say select star from customers where customer ID is equal to some value. Now we do have, we can get a value from our customer table. So let's go ahead and open the table. And we'll go ahead and just choose the very first customer. And we'll put that in there. So now if we set this into a local variable, and then let's make this to list. And that's no longer going to be a queryable object. And let's put a breakpoint so we can see what this returns. So now we can run our program. And we should see, so we have an error where this should be customers. Let's just rerun this. So now if we look at this, we have one customer object being returned back to us. So you could execute store procedures in here as well. But the problem is that if you were to run a store procedure, you would be bound to the objects that the customer classes, the properties of the customer class, basically. So if you were to take this customer history and add it here, you could, but that's not going to quite work, because if we look at the store procedure, and if we open this, you'll notice that this returns only 2 columns. None of the columns will map because we don't have any columns from the customers table. You would have to create a product object, or you could map it to a product object, but then what would you do with a total and how would you map that? So there are a couple of ways in doing this, and we briefly saw how a view that we executed returned some data, and the way it was set was that it didn't have a key. Well, store procedures doesn't have that either, because the results it is returning is just a set of record sets that are coming back, and there's no way to identify if one of them is a primary key or not. So we could do something similar to that, where we could kind of fake it and say that it's maps to a view, but it really isn't, and call a store procedure so we can just map it to our own custom object. So let's go ahead and do that. We can here create a custom object, and let's actually call this, let's just do public class, and this will be customer order history. And this will have 2 properties. The first property is going to be a string, and this is going to be our product name, right? So let's go ahead and grab the product name. And then the second one is going to be an integer value, and this is going to be our total. Let's also move this to its own class. So now that we have that in its own class, we can create a DB set for it. So we're just going to go ahead and copy that, and we're going to come back and fix this, where this is going to be our customer order history, and we're going to name it exactly the same thing as the class for right now. And then when we go to the model builder, so we're going to actually copy this, but we're going to delete some of the stuff that we don't need. Let's just delete all of that, and then what we're going to do is we're going to name this our customer order history, because that's going to be the object, and so the entity that's mapping, and then what view that is it mapped to. For the view, there is no view, so we're just going to say null. So now we have an object, and we have a DB set that maps to a view that does not exist, but and also has no key. So now we can go over here, and now we can say customer order history, and then call our store procedure. So let's take a look at how this is done in SQL. So if we come into our SQL, you can execute a store procedure this way, and this is results or returns. So all we have to do is basically grab this SQL statement and paste it here. And this should actually map the store procedure results to our customer order history class. And let's take a look at the results of this. So this will be customer order histories. Let's run this. And now if we go look at the results, we have 11 results, and as you can see, we have the data mapped to our object. So this is another way that you can execute store procedures. And if you didn't want to have the DB set over here, so if you didn't have this, you still have to do the mapping, because you need to tell the class and how it maps. But then within the program, when you go in to do this, so let's just copy that, comment this line, and from here, instead of saying that it's going to be customer order history, we can just say set customer order history from raw SQL, and this should also work. So let's execute this. And if we go back to look at the results, it's pretty much the same results that we had before. So this is how you execute a store procedure within EF Core. Now, there is another way to do this, and it's basically more going back to ADO.NET. And the way you do that is basically you first get a DB context, and then from the DB context, what you would do is you would get a DB connection. So you would say get, so actually first we have to go to the database, and then from the database you would say get DB connection, and this would return a DB connection. So once we have the DB connection, we can then create a command, which this will create a DB command object for us. Now that you have the DB command, you can then set the command text, and if this is a store procedure, so you could say, for example, the command type is going to be a store procedure. The command text would be the actual store procedure name, and then you would pass the parameters, and the parameter would be this value for the customer order. So there's another way you could do this, but this is very much more to how you would execute ADO.NET. So now let's take a look at another way that you could execute a store procedure that is not returning anything. For example, if you're doing inserts, deletes, or updates in ADO.NET, if you looked at that, you'll notice that when you execute a store procedure, it would return a int value for the number of rows that is affected. Now, to do that, but before we do that, actually, let's take a look. Why would you want to do something like that? The CRUD operations are easy because if it's just for one table, you can actually use the db context dot the categories for the the table that you're trying to insert and use actual EF core. But what happens if you wanted to insert to two or more tables? For example, let's say you wanted to you just took an order from a customer and you wanted to create a new order and then order detail and maybe the shippers and the products and the suppliers and all that stuff. And or maybe you wanted to delete the order for a customer, which you would delete the order details and orders. And let's say you had a store procedure that did that. And how would you do that? Because it would not be returning an object, it would return an integer value. Now, to do that was pretty easy. We can go back to our DB context .database, and then from here you would execute raw SQL. If we look at the return value, you'll notice that it's an integer value, and it's either taking a SQL, but it also can take parameters as well. Where we had over here, if you look at this as well, you can actually pass parameters for security reasons. You always should be using parameters. We just showed you a very quick and dirty way, but you should look at the other methods in here that actually uses parameters. So that's another way of executing store procedures that does not return, or maybe you're doing CRUD operations. So the last thing we'll go over is how to delete data from related tables. Now, if we go to our SQL Server, you'll notice that these tables have relationships. And we saw those in the SQL where they were constraints. Now, the reason you have this is so that data is not accidentally deleted. What that means is that let's say that we create customer, and that customer places some orders, and we don't want to be able to delete the customer if there's still orders here, right? Because then the orders will be orphaned. Right? We will not associate to a customer in the customer table. So that's why you have these relationships and the constraint that will not allow you to delete a customer if you have related orders in the orders table. So if we look at these tables where they have the many to many relationship, these tables don't have anything in them. So let's actually go to our table for that, and we'll go to this one, and this will open up the show data. So we're just going to create an arbitrary value for the customer type, and we'll call this test. So now we have a record. And now if we go to our customer demo and open or show the table data, we're going to go ahead and put 1 here. And then for the customer ID, let's go ahead and select the customer that we had over here. So now if we were to take the customer data and then associate this by retrieving the records, we would have data in there. So let's actually go ahead and delete these guys. So we can say where customer ID is equal to that. And let's also do a select star from our customer demo, where customer ID is actually basically the same thing. So let's actually copy that and paste it here. Now if we run this, so now we can see that we have our customer type of 1. So now we have our customer and it has a record here. And now this, we need some data into demographics. So let's show table for that one. So actually we do have data there. So let's go ahead and, so now let's go ahead and do our final select. Start from customer demographics, where for this one, it would be the customer type ID. It's this one. And this is equal to 1. This is actually, I believe, nchar. So we'll have to quote that. And let's go ahead and run this. So now we have our records. You are not going to be able to delete the custom demographics because we now have a record into this related table. So if we go ahead and try to delete that, if we say delete from customer demographics, and then we'll just use the same where clause. This is a little small, but you can see that there's a conflict. We can't delete it because of the there's a foreign key relationship and there's a constraint, so that's the error. Now to do this in SQL, we would have to delete the customer demo record and then delete the customer demographics. But how do you do that in our example here? So let's go ahead and delete that. Let's comment some of this stuff out. So let's actually create a customer variable, and we'll just do db context from our customers, and then we can say where our customer ID is equal to what we have in our SQL, and then we can say include. We're going to include data from our, it's going to be customer types. And then let's make this, because it's going to return only run record, we can say first or default. Let's get a little bit more real estate. Okay. So if we were to run this, we would get our customer and then we would get our customer types. So let's go ahead and run that. So here we have our customer object. And here we have our customer type, which is ID of 1 and the value is test. But notice that we didn't have the customer demo table, and that's because of the way this is set up and our in the on model creating. So if we come down here and look at our customer demo is basically hidden, even though we have a relationship set up between that, but then we have the customer demographic, but that is associated to the customer types. So if we were to delete this, it should be pretty simple. We would need to get the DB context, and this would be our customer demographics. And then we would say remove range, because this could be many records. And we would pass it our customer types, and this should delete everything for us. But actually, we're going to run to an error. So let's go ahead and execute this, see what the error is going to be. Now it's trying to delete from customer demo, and it can't because the customer type ID is part of a key and cannot be modified. We have some information here where it tells you that the foreign key, there's a foreign key relationship, and you cannot really delete that. One thing else we didn't do is that we didn't even call the save changes, right? So, but we didn't even get there because this was actually complaining. So to actually make this, to stick to the database, to make sure that the values are deleted from the database, you would have to do save changes. So now let's find out why this didn't work. So if we go back here and we go back to our customer where the relationship is, earlier we talked about that you had this on delete and how the delete would happen if you went and did this. Now we have this delete behavior that says client set to null. And if you read the description here, for entities that are being tracked, they would be set to null, but this is not going to work. So what we need is a cascade, which means that if we are deleting the principal record or the customer demographic, we should actually go delete the customer demo as well. So now if we go back to our program, and let's go ahead and execute this. So now it didn't complain, and let's go see if the data is deleted. So if we refresh this, we should have no records. And if we go to our outer table, refresh this, we should have no records in there. So this is how you can delete related data from the database without having to write SQL statements. You can just do it through EF Core. This concludes part 2. And in part 3, we will look at how we can do changes to our objects and have the Entity Framework Core create the SQL script or the SQL objects automatically for us doing migration. We'll also look into how to debug and see what kind of SQL statements Entity Framework Core is generating when we are asking for the objects to get data and so forth. Thank you, and we will see you in the next tutorial.